Dear students, in this video you will learn about use of synchronous condenser in power factor improvement, hunting in synchronous motor, use of damper winding to prevent hunting. First we will see use of synchronous condenser in power factor improvement in power system. The power system consisting of various components, generators, transformer, transmission lines. So, due to the inductive loads, due to the inductive nature, so power factor will be decreased. To improve the power factor, so we are using the synchronous condenser. So, nature induction motors, inductive loads will decreases the power factor. So, due to the lagging power factor angle. So, for low power factor, due to the low power factor in power system, so which is increases the cost of generation, cost of distribution and cost of transmission of electrical energy. The cost will be increases since power formula P is equal to VA cos phi. So, here P is true power, V is supply voltage and I is current, cos phi is power factor. Power factor is decreased and power will be decreased. So, to improve the power factor, so once if you improve the power factor, power also we can improve, generation of the electrical power will increase. So, hence such low power factor needs to be corrected. So, should not decrease power factor due to the inductive loads. So, here we are using synchronous condenser to correct the power factor, synchronous condenser, capacitors. So, we are using, so if you use synchronous condenser and capacitors, the power factor angle will be in leading position, automatically power factor will be leads and power will be increased. Such power factor corrections is possible by connecting the synchronous motors across the supply and operating it's on no load with over excitation. Okay. So, here let B phase is the phase voltage or applied voltage to the synchronous motor, I phase is the current lagging by V phase. So, angle is pi 1, the power factor will be in lagging in nature, power factor will be decreased. Once motor is connected to the supply, synchronous motor is connected across the supply, the current draws from the supply will be in leading position. So, synchronous motor is acts like a capacitor, right. So, by connecting the synchronous motor or synchronous condenser or capacitor, so we can improve the power factor. So, here we can see the two cases without synchronous motor and with synchronous motor. So, with synchronous motor, so we can see I2 current flows in the motor and without synchronous motor I1 current. Okay. So, here the current drawn from the supply in is now phasor of I phase and I2 phase. So, I phase is I1 consider without synchronous motor, I2 is with synchronous motor. The total current is IT. So, you can see effective current. So, now even though the current lags the voltage, the power factor is gets improved. So, angle is decreased and power factor will be increased. Okay. So, you can see with and without synchronous motor how the power factor is varies. And hunting is a main disadvantage in synchronous motor. When the no load condition, so rotor gives the oscillations, the rotor speed will be oscillations, rotor will gives more oscillations. To decrease that one, we need to have a damper windings in synchronous motor. Hunting means rotor gives the oscillations. So, we have to remember rotor is not rotating in same speed or constant speed, it will give oscillations. Okay. So, synchronous motor is on no load, the stator and rotor poles axis almost coincide with each other. Okay. So, there is no induced EMF, then this will be coincide. The motor is loaded, the rotor axis falls back with respect to the stator. So, here the load angle delta will be varies without load and with load. If the load connected to the motor is suddenly changed by large amount, then the rotor tries to retarded to take its new equilibrium position. See in this graph, so we can see the various positions of the rotor axis. So, and also you can see the delta load angle delta varies. So, due to such hunting, the load angle changes about delta 1, delta 2, delta 3 you can see here. So, delta is the equilibrium position. So, when the load is changes, rotor positions will changes, rotor gives the oscillations, that is called hunting. Hence, during hunting there are changes in current drawn by the motor. So, we can see IA1, IA, IA2. So, which may cause problem to other appliances connected to the same line. Okay. Right. So, to eliminate hunting in synchronous motor, so we need to have a damper windings. So, use of damper windings to prevent hunting. So, hunting will be prevented by damper winding inside synchronous motor. So, it is mentioned earlier that in the slots provided in the pole phase, a short circuited winding is placed. So, a short circuited winding is called damper winding. So, where the slots are there, we have to place the short circuited winding. So, that winding is we are calling as a damper winding. So, with the damper windings we can prevent the hunting. When the rotor starts oscillations, when hunting starts, a relative motion between damper winding and rotating magnetic field is created. So, due to relative motion, EMF will be induced in damper winding. According to the Faraday's laws, EMF will be produced. According to the Lenz's law, the induced EMF is always oppose the supply voltage. So, opposes the producing it. The cause of hunting is rotor oscillations. So, rotor is oscillating, then the hunting will be produced. To eliminate that one, so we are using damper windings, right. The induced EMF tries to damp the oscillations as quickly as possible. So, using the induced EMF oppose the supply voltage according to Lenz's law. So, which will be damp the oscillations of the rotor windings. So, thus finally what we can say, hunting is minimized due to damper windings. So, by using the damper windings we can minimize the hunting in synchronous motor. So, here we can see the load variations in this graph using the effect of damper winding. The time required by the rotor takes its final equilibrium position after hunting is called setting time. So, setting time we can see, hunting period you can see without damper winding. So, setting time is there. The load angle is plotted against time in this figure. So, against the load angle and time you can see the graph. So, here setting time is less when we use damper winding, otherwise the setting time will be increased without damper winding. So, damper winding without the setting time is more, with the damper winding setting time is less. So, by the time rotor will give the oscillations. So, using these damper windings, so we can reduce the setting time and also we can reduce the oscillations of the rotor, okay, and also we can increase the efficiency of the synchronous motor, right. So, in figure shows the due to damper winding the setting time of the rotor reduced considerably, okay. So, without damper winding this much time, so with damper winding setting time is this much, okay. This is about damper winding on hunting, okay. So, in next video, so we will learn about methods of starting synchronous motors, okay. So, various methods we have 3 methods using pony motors, using damper winding, as a slip ring induction, motors. So, these are the various methods of the starting methods. So, we will see in next video. Thank you everyone.